So I just started recording, so I'm going to go ahead and do that one more time. Hello, everybody. Thank you so much for joining me. I'm Eric Cox. I'm a member of the Netcapital team. Let's allow one moment for folks to settle in, and then we'll dig right in with our live Q&A with Invicta Water. Thank you so much. All righty. Folks are still trickling in, but let's go ahead and get started. Thanks again. Welcome again. Today, I'm excited to be here with Steve Walensky, the CEO and founder of Invicta Water. As always, this company is actively raising capital on the Netcapital platform. You can go to netcapital.com and search Invicta Water. You can select the link that I added into the chat feature in Zoom, or you can go directly to netcapital.com/companies/Invicta Water. A few quick housekeeping items. Please do use the Q&A feature built into Zoom. I know there's also a chat feature, but Q&A makes it so much easier to track the questions as they come in, and we do want to answer as many of those as possible. So please do ask your questions, and please do use the Q&A feature. We really want this to be interactive. With that being said, please join me in welcoming me Steve here. Steve, thanks again for joining us. Why don't you tell us a little bit about what you're building with Invicta Water?
Yeah, appreciate it, Eric. We look forward to these. We enjoy the Q&A, so I would just like to encourage really any questions that you guys have, please post them. I do not have a PowerPoint presentation or anything to share today, so really this is just a conversation. This is just an opportunity to give you a little bit more information about what we're doing. And what we want to do, big picture, is we want to change the world through material science. And that's been a goal that we've had really since we started all of the things that we do. And specifically, what we're trying to do is we're trying to change the world by providing clean water. And, it's hard to imagine a more strategic or a more valuable resource in the world today, and something that's also as simple. It's everywhere, but it really is a challenge for people, even in the developed countries, to have clean water. And what we're plagued with here in the US and other parts of the world are these PFAS contaminations. And these are chemicals that are necessary. They do a lot of good, but unfortunately, they do have some toxic side effects. And they really earn that name forever chemical because they just don't break down in nature. So we have to find a way to destroy them. Current methods of removing PFAS from water, they do just that. They remove them from water, but now you still have a contamination that you have to do something with. Oftentimes it's buried, which can leak, or it's incinerated, which can have bigger problems. So what we've been able to do is, using materials technology combined with existing water treatment technology, and we have found a way to design a system that not only removes PFAS, but exactly the same time it destroys it. And it destroys these chemicals by breaking the bonds. And that carbon-fluorine bond with what makes up PFAS it's among the strongest bonds out there. And having the ability to locally break those bonds and destroy these chemicals, it really is a differentiator in what we're doing. And we're able to do it in a way that doesn't require a lot of energy, doesn't have a lot of cost, and it's a remarkably efficient and small footprint type of technology. So we're pretty excited. It changes that cost benefit analysis. It changes the amount of capital, the amount of OpEx you need to get rid of PFAS. So we're really excited. We're well beyond the lab. We know the science works, and we are actively preparing for our first pilot, which we expect to be here in the state of North Carolina. And then we're engaged in a number of conversations with a lot of other folks, from small industry to larger industry to other governments and municipalities. So we're excited, and we're glad to be part of the Netcapital community again. We welcome input from the people that watch us, the people that invest in us. We get a lot more value out of the crowd than just investments. So any introductions you have, any ideas that you have, any questions you want to pose, oftentimes it sparks something in our minds, or it makes a connection that we didn't have before. So we appreciate that.
That's so helpful, Steve. And we're always so grateful for your kind of willingness to be in here. You engage with the discussion board really kind of actively, and we're so grateful. And I think your investors are super grateful for that. Without going to the specifics, and we'll keep going on to other topics as well, but without going to the specifics, can you share a little bit about the recent support that a community investor had, and helping open some doors for your team? And again, I know you don't want to get too specific here, but
Yeah,
any
without getting
details you can share
specific.
about that?
Yeah, this is pretty common. What we'll get is, we'll get an email to us, usually directly, and it'll say, "Hey, I'm in either an investor in Invicta Water, or maybe they've even invested in our parent company, BN Nano," and they'll say, "Small investor, but I have an idea, or I work for this company, and we are engaged in PFAS cleanup right now. And would it be okay if I make an introduction to some other folks in the company to see if this works?" And our response is absolutely. We've had other people, comment that, they love to evangelize about us, to tell people what we're doing. And sometimes they'll send us a note and they just say, "Hey, I just want to be sure I'm saying this properly, or am I overstating what you're doing?" And for us, that's fantastic. And I think the biggest thing for us, no matter what we do, no matter how technical we are, fundamentally, we are still a business working with people. And it's those relationships that grow everything. So having folks that are advocating for us, that are also invested in us, it's a really cool thing. And we are growing in some regards because of the crowd. So they are not just investing, but they are making those introductions. They're connecting those dots, and they are giving us ideas that we might not have had otherwise.
So glad to hear the extra value add besides you raised quite a bit in different companies. And so it's not just the pure capital, also the feedback from the group. So I love hearing that. And we have some great questions coming in the Q&A, but I don't want to get off track too much. I want to at least give a chance for you to tell us a little bit about who's Steve, right? For those who are unfamiliar, do you tell us a little bit about yourself, and then some of the other key team members that are helping make this project go. And then I'll start digging into some of these Q&A.
Yeah, sure. So I am, by education, I'm a material scientist, and I'm also a chemist. I have been a process engineer, I would say, for the first part of my career, and all that really means is we were in the business of making things. We weren't in the business of inventing, or we weren't in the business of just working in a laboratory. Our goal was to commercialize cutting edge technologies, and I've been very fortunate. I've had some really cool jobs. My first job out of college, I was making solar cells for satellites. So I have devices that are still closer to the edge of the solar system, even on the surface of Mars. Worked for another company where we were working on revolutionary LEDs, different colors and different interesting things. Got bored with 2 dimensions, and for glutton for punishment, I went into 3 dimensions and started working on micro and nano machines. I was part of the teams that were some of the folks that made really the beginning of the Internet of Things, the sensors that are ubiquitous today, that are in your cell phones, and your game controllers, and your cars. Were part of the teams that really commercialized that technology. And then along the way, Jason Taylor, co-founder, and I, we worked together at a previous job, and we had always kicked around the ideas of starting businesses together. And Jason is also a material scientist, also process engineer, and we came up with some ideas, and then we grew the team. Mark Edmond is another key contributor to what we do. We've worked together. All of us started working together in the late '90s, so it's a core of people that we really know each other. We really trust each other, and we've always made things. And I think that fits perfectly for what we're trying to do now. We have this unique technology that we're really the only ones in the world that have access to, and we've been able to figure out how to commercialize it, and how can we commercialize it in such a way that we can grow a company very, very quickly. So it's a small group, that that core team, and from there we've grown. And like I said, we've got a number of people that work with us directly. We have a number of people indirectly, and then we have a number of people from the crowd that we have kept in touch with over the years, and we've even retained as advisors, consultants, and part of what we consider to be our family.
Oh man, you love to hear that, team. So an opportunity to join the family. A reminder that the link to the offering page is in the chat if you want to learn more from the offering page and potentially invest. For those of us who are just now learning about PFAS or forever chemicals, or maybe we haven't even heard those phrases yet, can you tell us a little bit about what is the problem? And you alluded to it in the beginning. Let's take a deep dive. What are the real consequences of PFAS living in our drinking water, and then when we consume them?
So the PFAS there are chemicals that have been around on a commercial scale, I would say, really since probably the 1940s. And these are chemicals that do have quite a bit of value. They do a lot of interesting things. If you have something textile that is waterproof, or if you have a fire extinguisher that's foam based to put out fires, and if you have things that are non-stick, contact lenses, there are food packaging so that your food doesn't stick. There's a lot of different materials that have these compounds. There's thousands of them out there. The problem is they are extremely stable. Like I said, that carbon fluorine bond is extremely strong, so it just doesn't break down. It doesn't break down over time. So what happens is, as these things are thrown away, as they're used in different types of processing, they do get into the water table. And as they get into the water table, then they get into your plants, they can get into the animals, they can get into other areas, and they tend to bioaccumulate. So even though you're exposed to very small amounts of these materials over time, they build up in your body. And it's not completely understood what all of these things do, but they've been linked to a lot of health problems, different birth defects, decreases in fertility, increased risk of cancers. There are a lot of, I'd say, high profile stories out there. There was a movie, Dark Waters, that talked about the effect of PFAS. The Philadelphia Phillies at Veterans Stadium, people believe that there's been some problems associated with, the turf that was used there over the years. There's a lot of, news stories associated with that. We have a lot of links on our offer page and our websites, but these are chemicals that at the time, nobody really knew that they were going to cause a problem because it took a number of years to see these effects. They're very prevalent in areas where there are airports, anywhere where there's military, anywhere where there is a high concentration of industry is sort of these clusters of where you're going to see these things. But PFAS have been found literally almost everywhere. They've been found in Arctic ice. They've been found in the rainwater in the Australian outback. It's estimated to be more than 80% of all the U.S. waters are contaminated with high levels of PFAS. So it's been a challenge. And earlier this year, the EPA announced pending regulation on only 4, maybe it's 5, might be 6. I can't remember the exact number, but there's 4 main ones that people are worried about. But they're beginning to regulate them in drinking water. And that's the first regulation. It's a few compounds out of thousands, so it's just a start. But people are beginning to come aware, corporations are becoming aware of what they're doing. So there is still a portion that are reacting to these pending regulations, but what we're seeing is the beginning of proactive behavior to try to go in and remove these things before they are forced to, because it's the right thing to do. The challenge is, again, until really recently, there hasn't been a good way on a very large scale to both capture and destroy them at the same time. And that's what we've been able to do. We've been able to find a very cost-effective, efficient way to do that.
And that's critical, because we do love our non-stick surfaces. We love our clothes, our water-resistant clothing. We love our Teflon, or like what do you call non-stick pans and cookware and things like that. But the concern is leaching into water systems and like consuming the bioaccumulation. It just retains in our body. It seems to hold into our bodies longer than folks expect. And it's hard to study this stuff. It does take quite a bit of time to discover. Absolutely. And we're still, I think, very much learning the consequences of PFAS. But we love them. We just want to figure out how to keep them within their lane. so
Absolutely.
Awesome. And then let's start taking on some of these questions here. So somebody mentioned that they saw the short video with the small water filter. Does the filter need UV light to completely break down PFAS? Good question.
Interesting question. So the video that we had, absolutely correct. And I think that's a very good observation. Our first prototype does not have UV in it. So what we see is so there's been a lot of, we've been asked this a lot, and we've had a lot of commercial customers and even some companies ask us if that's something we can do. So what our material does is it does 2 things. So the surface of our catalytic crystals attracts the PFAS, and it does that by a process called adsorption. So it's adsorption. So it essentially sticks to the surface. So by having a filter without the UV, we do have the opportunity to remove it from water. But what we have there is then we have the same problem that other potential solutions have as well. You have moved the contaminant from one place and put it into another. So to be able to do that on the consumer scale quickly, we could have a system that would not have UV light. And what that would require, that would likely be a subscription type filter where they would use it for a certain amount of time. They would send it back to Invicta Water, and we would handle the destruction in a larger system, and then we would replace that with something else. But we do envision an opportunity to design a filter in such a way that we could maybe have a base where it sits so that we can incorporate UV light in that filtration to do the destruction at the same time. Shorter answer is, yeah, you have to have UV to destroy it, but a filter to remove it could be something that we could get into the marketplace pretty quickly. And then as we progress, we could find a way to shrink down that UV energy to have it where it could fit in a pitcher or something that you drink out of.
And as we talk about the consumer applications and being in people's homes, I know there's so many different applications. We're talking about the business to business for these larger institutional players that use a lot of water. Can you talk about how large the market is, including the business side and the direct to consumer, or any data you have?
Yeah, so there's a wide ranging estimate of how big the markets are, and the way we look at it is municipalities, which would be your government run drinking water and wastewater plants. That is the industry where we're beginning to really start first. That could be, certainly greater than $100 billion a year. But if you took the average amount per gallon of water that's being spent at some facilities, and you extrapolated that across how many water facilities there are in the US, now you're talking closer to 5 or 6, maybe $700 billion that they're going to spend on that. Now, our solution is significantly less expensive. So even if all of those converted to Invicta water, it wouldn't be that high, but that just shows you that there's a tremendous opportunity from the municipality point of view. And that would be the largest systems that we would possibly do. Those are millions of gallons of water per day. On the industrial scale, it's also pretty far north of 100 billion. And again, it depends on how you break things down, but we look at industrial in a few different ways. One, there are the large manufacturers, semiconductor plants, pharmaceutical plants, other manufacturing, all the way down to food and beverage, and even down to, say, microbreweries. So having that PFAS-free label on a bottle of water or an energy drink or a beer or a beverage or even food, if you talk about hydroponic farming, some other things, we believe there's a lot of value there. The consumer business, from what we see, the U.S. is probably the largest consumer of these personal filters, and that is estimated to be north of, say, $50 billion a year. And that's before you even go international in some of the larger communities or some of the larger population areas that just haven't gone to using those yet. And then you also have the remediation side of things. So the cleanup, right? It's hard to estimate what that might be, because I think the value is well beyond the revenue that would bring in. But if you could imagine, if you could put something on the back of a truck that you could drive up to a spill or to a retention pond that has some challenges, and you could pull out the bad water and pump back in the good water, that's something that we would also be pretty focused on. So it's a large market with a bunch of different verticals. The beauty behind what we're doing is our catalytic crystals that we would use in that personal filter for the consumer is exactly the same that we would use at a water treatment plant in a municipality. And really all we need to do is scale the technology. So it is one material science that is using to do the purification across all of these different applications.
No, that's exciting to have those large of addressable markets in all different industries, and all of them really kind of approachable with the same hard work that you're doing right now on the everyday filter. So can Invicta water clean any wastewater or only water with a concentration of PFAS? Interesting question.
Yeah, so boron nitride as a material, it has tremendous capabilities. It can do a lot more than just PFAS. And we are doing experiments for other organic molecules, over-the-counter pharmaceuticals that get dumped down the drink, things like artificial sweeteners, nicotines, a lot of these things that are classified as emerging contaminants that we're not yet really studying or regulating. We've been getting to do work on some of those to get ahead of that. But I think what he's asking is, can we clean really polluted water? There are better ways. There are probably cheaper ways to do that. When you get water out of, say, that leaches out of a landfill, it's called leachate. And if you looked at a glass of that, it's going to look like coffee almost. It's a very muddy brown because it has a lot of different things in there. There are a lot of steps that you can do that you can do on a very large volume that can get rid of a lot of the vast majority of what would be the main pollutants. So if you think about this like an air filter, if you had a HEPA filter, there's usually a pre-filter that filters out the big stuff before the cleaner air goes through that HEPA filter. We're kind of like that HEPA filter. We would be close to the end, but we are actually right now beginning to do some studies on how our material would be impacted by things like the leachate and some of those bigger things. So it can do that, but there's probably better ways to get rid of, say, 90% of the large contaminants before we start doing the catalytic breakdown that our material provides.
No, that makes a lot of sense. So yeah, essentially cleaning the water and then wiping out the PFAS might be the smoother of the options instead of doing it
Yeah,
all at
we
once.
like we visited the water treatment plant close to where we are, our manufacturing facility, and their first holding tank. You look down and you see things like clothes and bikes, just all the big stuff. And so that's what they get rid of first, and then it goes to the second stage, and that's where they clean out some of the biosolids and some of their things. So there already is a way to sort of do that in series. You take the big stuff out, and then you kind of go down, and we would be closer to the end of that process.
Okay, that makes a lot of sense. And I imagine if you want to be somewhere in the flow, you want to be probably closer to the end where no matter what you need to do it. Even the cleanest water, we got to wipe the PFAS. So a nice
Yeah,
place to be in
and
the flow.
the challenge is if because if you think about the amount of PFAS in water is pretty small, right? So if you had 100 million gallons of water, you probably have a pint of PFAS, and that pint is equally distributed around that 100 million gallons. So part of the challenge is how do you combine it to where you get into a smaller volume to where you can then treat it with the crystals. And what we've done is we've piggybacked onto existing technology that does just that. It gives us the opportunity to have a continuous flow of water while we're moving the bad stuff into a smaller area or a smaller volume so that we can concentrate our treatments in that smaller area, but always have a continuous flow. So we're not doing something like a batch to where you have to spend a lot more energy and then release it. It's a low energy continuous flow.
That makes a lot of sense. That's probably pretty critical too, so that you're not just continuously cleaning the already clean water if you're pumping it back into the same source pool. No, that's awesome. And then I know you talked a little bit about some of the advantages of being able to destroy real time while you're separating. But what do you view as like your core couple of strategic advantages over other players in the space?
Yeah, so there's actually quite a few. Cost is certainly one of them, and there's a water treatment plant in Wilmington, North Carolina, which is on our coast that we like to compare to, and they spent it's public knowledge. The information that we are citing is what we've read in public documents, so we don't have information on the exact numbers, but they spent somewhere around $40 million to dig giant holes that they fill with carbon, and by giant holes, multiple Olympic-sized swimming pools. And that carbon needs to be replaced over time because all it does is, again, it pulls it out of the water, and they still need to dispose of that. 30 to $40 million they spent doing that, and they'll have considerable, multi-million-dollar operating expenses every year. We would be a fraction of that cost. But another thing that is just as big of consideration, Wilmington they're lucky in that they have the land to be able to dig that many large holes. So when you start going into higher density areas or some cities or places, say California, they really don't have the ability to have acreage to use for something like this. So we also have a very small footprint, and there's a tremendous amount of value there. It's very low energy, so the operating costs are low. And then the other value that we bring is the time to install is short, right? It should be months instead of a year or two to do some of the things that they're doing now. And then the other thing that we have is we can customize the equipment to the toxic chemical or to the compounds that we're trying to remove. So we have a sort of I would say a generic or a standard system that will go for the PFAS that are being regulated or being proposed to be regulated. But if, say, it's a manufacturer and say, well, we know exactly what our compound is, well, we can tune it to approach that. And the beauty is, well, if a year from now, if they have a new compound, all we need to do is make some other changes to what already exists. So we don't need to replace it or add on, but we can just change the way that we have our interactions with those contaminants. So it really is, it's a suite of advantages, and it's disruptive to the industry, right? Today, if a municipality water treatment plant wants to have a solution, they typically will engage an engineering firm who will do a study, and then they'll do a plan, and then they'll do the implementation. You're talking probably 12 to 18 months, millions of dollars before you really even get equipment on the ground. We need to know how much water are you pumping, what might be in it, and how much land can we take up? And then we can just chart out, what equipment you need to buy. So it's not only a disruptive technology, but it's a disruptive model. And it really knocks down that cost barrier from people saying, I would love to get rid of the PFAS, but I just can't, spend that much money. Now that goes away, and now we have an opportunity to do it in a cost-effective way as well.
No, huge competitive advantage being able to streamline the processes and keep those costs down. That's massive. I do want to recognize that we're about halfway through our scheduled programming here, so I do want to remind folks we're online here with Steve Valensky, founder and CEO of Invicta Water. They're actively raising capital on the Netcapital platform, so you can click the link that I just added into chat once again, or you can go to netcapital.com and search Invicta Water, or you can go directly to netcapital.com/companies/Invicta Water. So I just wanted one more shameless plug there. Got to remind the folks why we're here. And we have more questions coming in, so this is so great. Please continue to ask your questions in the Q&A. What happens to the residue after it's removed from the contaminant? So what do we do with the
So the bonds are the molecule is actually broken down. So it breaks the bonds. It breaks the chain down. So what you end up with is you get a little bit of CO2 off gas, and again, a very small amount. And then you get ultimately what turns out to be a very small amount of an acid, of a fluoride acid, HF. And you can combine that with, say, like calcium or some other materials, and you create like calcium fluoride, which is kind of like what's in toothpaste. So it breaks it down into very innocuous different molecules. But again, there's a small amount. So it's not like we are creating a greenhouse problem. It's a very limited amount of CO2 in there. So it actually destroys it. So it takes the forever chemicals and it removes them forever. And it breaks them down into simple molecules and things that aren't harmful to us.
That's awesome. And we got a nice new long question here with some context, but I do love the idea of removing forever chemicals forever. So question coming in, there are currently whole home UV units for well water systems to sterilize for possible bacteria contamination. Penn State University is currently initiating a water sampling study to analyze for a suite of emerging contaminants such as pharmaceuticals, personal care products, pesticides, and PFAS that may have federal regulatory standards. Any thoughts about leveraging that study? Thanks for that feedback.
Absolutely, and that's what we like to do, right? We want to invent as little as possible, because invention takes a lot of time and it takes a lot of money. So what we want to do is we want to take things and technologies that exist and we want to innovate on top of them, or we want to change the way they're used. So it's really, that's what we've done. There are a lot of other UV technologies for other things in industry and else, but I think this is fantastic. I think this is phenomenal. So what we would do is, for something like this, the difference that we add, when you are flowing water through some of these systems that have UV, you are working on the probability that UV light will interact with the chemical at the right time. With what we're doing, by having our materials, we are creating a surface that we know will have the PFAS or these emerging contaminants on top of that surface. So we can direct that UV light to where it needs to go. And one of the really creative things that we're doing, a partner that we've worked with, that we've had some videos posted by them and we've talked about working with them, is a company called TrueSpin out of Alabama. We are working with them to find a way to blend our material into a matrix, so something that looks almost like an air filter, like a furnace filter, so that now we know a surface that is completely coated with our material. So what that would do is that would give us that target. So now we know where to focus that UV energy. So we're not wasting energy just blasting it out everywhere, but we're targeting in a very specific location. And that gives us the opportunity to be more efficient, more effective, and to also to do it cheaper.
No, that's fantastic. So yeah, always helpful. Please continue to reach out. Steve is incredibly, kind of engaged with his community. So if you want to share that link, I'm sure he'd be grateful to see it. And I do think
absolutely
incorporate it as needed. And then great question, putting us right back on track with some of my prepared questions. So let's talk a little bit about the intellectual property. Do you have approved patents on your technology or processes? Yeah, let's dig in.
So, obviously the material that we use is based on BN Nano's boron nitride nanotubes, or their nanobarbs, and Invicta Water does have exclusive rights to that material in water treatment. So from that perspective, there's a patent there. Now, if you, and there's a picture of this on our offer page, we have 3 stages to what we do. We have the stripping, we have the enrichment, and the destruction. And in the stripping is sort of the big, where we're getting as much of the bad stuff out as quickly as possible. The enriching, we're getting it kind of closer together. And in the destruction phases, when we're actually breaking those bonds. Each one of those areas, we do see an opportunity for IP, patentable, and also trade secrets. And what we're doing right now is we are going through that evaluation of what do we think we should or could patent, and what do we want to maintain as a trade secret. And it's a delicate balance. It's not only, what are you trying to protect, but the cost of patents are quite high. And when you do have patents, you are disclosing publicly what you're doing. And there are a lot of places where people will take advantage of your patents and not necessarily follow them. So, there is an art to that. And I will say that, our team going all the way back, we all hold patents. I have some patents from other technologies. Jason has a number of patents. Mark has quite a few. Our team, the founding team going all the way back, has hundreds of patents in different industries. IP has been ingrained in us since really, we started working. So it's something that we fully understand the value of IP, but we also understand that sometimes a trade secret is worth more than a patent. It's certainly something that we are continuously evaluating. And with the changes in the patent laws, you do have the opportunity to file provisionals at a relatively low cost. So that is something that, we are taking advantage of. But absolutely, IP will be important on really all aspects of what we do.
Yeah, absolutely has been and will continue to be. It is a really delicate dance. It's definitely more of an art than a science, IP strategy. And I really do like to frame it in that context. It's not just
Absolutely.
one patent and done. It's really a whole suite of different types of IPs, from trademarks all the way to trade secret. So it's great to hear that you've been really thoughtful about which intellectual property rights to enforce and in which capacity. Great question there, and I think a great answer too. Digging into a little bit into the nitty gritty of the business, can you share a little bit more about the revenue model and your plan to make money for Invicta Water?
Yeah. So again, we want to kind of break it down into the different areas that we talked about. There's the municipality side of things. And so the municipality would be the largest systems. So when you think about those, again, those are the first pilot that we're going to do. The wastewater plant handles, I think, somewhere 5 to 7 million gallons of water per day. So that gives you the idea of sort of the first full production size, if you want to call it full production. Our pilot will be a percentage of that just to demonstrate that it works. So if you look at a municipality like that, that would be a small, less than 10, but certainly multi-million-dollar type of business. There are a number of municipality plants around the country, but so that would possibly be, a good way to get a lot of high dollar revenue. In the industrial side of things, there's really two opportunities. There's the large users, say the manufacturers, which we would likely see, they would be treated like the municipality. We would sell them equipment, potentially maintain it or help them operate it. But there's also the smaller end of the industrial scale. If you start talking about food and beverages, microbrews, energy drinks, we believe, because of the cost of our equipment is relatively low, that we see a leasing model for those folks. To get them to where you're only adding, say, a fraction of a penny per gallon or a very small amount per gallon, because a lot of times they have much tighter margins. They probably don't want to spend a lot of capital and they don't want to do a lot of maintenance. So we'll lease it to them. So, that's a model that we're working towards right now. And then there's that consumer, the direct to the consumer as well, which would be most likely on the personal filter side of things, a subscription model. But also well water and some of the, the under the sink type applications where we could more easily incorporate UV energy to do the destruction. We could see those as, off the shelf products that you could buy at, some of the big box retailers, home improvement type stores.
I love hearing multifaceted revenue models.
But the key there is we run into this a lot. People will say, well, you guys aren't focused. Well, it's the same exact material. It's the same exact technology. We just changed the size of things. Now, the difference there would be that personal filter is different, but the under the sink to the well water, to the energy drink, to the pharmaceutical, to the semiconductor manufacturer, to the municipality is all the same technology, just shrunk down or expanded in size.
No, thanks for adding on those details there for sure. It's really helpful that it is all stemming from the underlying technology that you guys have mastered. Let's talk a little bit about your progress so far, and then we'll kind of peek into the backfield a little bit and see if we can think about the future. But tons of traction, obviously. Can you tell a little bit about your progress and specifically some of your major milestones to date?
Yeah, so we are, we don't like to talk publicly about what we're doing until we're confident that we actually can do what we say we can do. So we've been working on this for quite a while, and it's really only, I would say, the last 6 months or so that we've really started telling the world what we're doing. And we can do that because we know that the material science works. We know that we can adsorb the chemicals, and we know that we can destroy them with UV light. So we've done all of the things that we need to do to demonstrate, to produce the data to show that what we have works. What we've begun to do is to scale that up. And we said we are waiting for really just the dots on the I's and the crosses on the T's to start our first pilot here in North Carolina. And that'll be our first industrial or municipality scale project. So that is something that we're quite excited about. And so we've demonstrated the technology that works. We've been working with the U.S. Navy has also used our material to show that it works as well. So we know that someone else has been able to do it. And then some local universities, we have a professor at a local university just down the street from us, Elon, which is they've been able to demonstrate in their laboratory that it works as well too. So it works. So now what we're doing is we are just going up that chain. So we have that first pilot. Again, we're just waiting to finalize the contracts. And then we have a number of proposals out for industry users. So we're quite excited about that. And then we are also, based on a lot of really a pull from the industry, we've really started working on that personal filter. We thought that we were months and months away, but with partly because of the work that we've done with the company that I mentioned previously, TrueSpin, we've been able to find a better form factor for our material to help develop something like that consumer filter quicker than we thought. So we're preparing for the first pilot. And then after that, there's a number of people that didn't want to be first, but would love to be second. So we're really excited to get that first one going.
It's huge. We joke around all the time that investors are often interested in being the first to be second. And that's
Exactly
not just
right.
investors,
Yeah.
that's users and pilot projects. Everybody wants to be the first to be second in these industries, it seems. Congratulations and welcome to the family. Just had an investor that is on the line right now, an attendee on the line that just invested in Invicta Water. So welcome to the family, to that person. And as we start to transition over, we just got a great question that's really interesting. Can this filtering methodology be used in various water-heavy industries? Example, battery production. Can it be used for extracting other elements like direct lithium extraction? I'm not sure if you've, yeah.
The short answer is I don't know for sure. I don't know. But this to me is what we talked about earlier. Questions from the crowd, questions from the people, they'll pose this question. We do know that it does work for some heavy metals. There is a lot of literature that's been around for really decades on boron nitride materials. One of the conversations that we had very early on was a government group out of the Far East, Malaysian type, and in the Ring of Fire. And so in the Ring of Fire, they have a lot of heavy metal contaminants from the volcanic eruptions, and that's a problem with some of their waters. So it's something that we're looking into. Short answer is I don't know, but I'm sure Jason's watching. And he'll be looking into probably next time I talk to him, he'll already have a theory and thoughts on how we can get into things like lithium extraction.
Oh, I love that. That's what it's all about. Thanks for that question. I was like reading it. I was like, wow, that's a really interesting thought. So I'm glad that you brought it up. Please do, as a reminder, this is exactly what this is for. Please do ask your questions in the Q&A. We want to keep this interactive. So thank you for that question.
And one of the things I'll just bridge from there, which is another interesting thing, is I think I mentioned before that you can kind of envision that the new material that we're making kind of looks like a furnace filter for your house, for an air furnace. We think that an evolution of what we do is an air purifier. And there have been experiments done with boron nitride nanomaterials to where it can be used for this what we're doing to catalytically destroy the PFAS. It's able to catalytically convert things like methane into things like methanol. So you can take other areas or other contaminants and turn them into usable things. I know in North Carolina, there is the hog industry is a large industry, and there have been some studies to show that the air contamination is causing health effects with people around the area. So if you could collect that air in such a way that you could flow through these filters and you could then create some of these things into a usable material, then there's lots of opportunity. Now, you also have ammonia, you have hydrogen sulfide, you have some other things that we don't know if we can do it, but it's part of the roadmap, not just water, but potentially air as well.
That actually puts us perfectly onto that next question about next major milestone. So you're already talking about air purification, what an exciting application there, and seeing what opportunities lie there. Are there other major milestones that you see in the near-ish future that, again, I'm going to do the massive caveat that the future is incredibly uncertain by nature. There's no guarantees here, uncertainty. So yeah, any ideas about some of your next major milestones that you hope or project or predict might come through?
What we're, again, don't know for certain, nothing certain. And what we're doing in a lot of cases, if we're starting with governments, there's even more uncertainty there because nobody really knows what they're doing sometimes. So the first major milestone will certainly be that first pilot. And while we expect that to be in a municipality, I would not be overly surprised if some of the industry folks that we're talking to leapfrog that and we get that going first. I am cautiously optimistic that we will have, be able to announce our first pilot of the details behind it in the next few weeks. I'm also cautiously optimistic that we will have a system working by the end of the year. So it just depends on, how large that is or how quickly it is. I would like to say that we'll have some other improvements, new prototypes for the pitcher filter, if you want to call it that. I think that would be, important for us. But really what we're focused on right now is the business side of things, getting those first sales, getting those first pilots. And really, as you said it, and I'm probably going to steal the way you said it, nobody wants to be first, but they want to be first second, or the second first, or said it. So we have a lot of people that are just waiting for that. And I think that will be getting that first pilot out there is really going to open up the floodgates. No pun
That's a
intended.
good point. I mean, no, that's a good point. I'm super excited about the municipal application, but I do imagine there's a possibility for an Anheuser-Busch or a smaller beverage manufacturer, any of these. I love when we talk about microbreweries that are really thoughtful about environmental
A PFAS-free label, right? I mean, we're having conversations with folks, and they're trying to understand what the value of that PFAS-free label means to them. In some cases, it's a reactive decision. In some cases, it's proactive. They want to go ahead and be on the forefront of doing the right thing.
That's super exciting. As we're talking about these uncharted territories that are the future, what are you worried about? Are there concerns that you think about the future that might disrupt some of these things, and how are you kind of working to kind of
So again, we're as a group of process engineers that have, our job has always been taking what somebody's done in the laboratory and do it millions and millions and millions of times. We know there's a challenge when you try to do that. So obviously, all the homework that we're doing and all the preparation that we're doing, until you actually have something installed and running, you don't know what you don't know yet. So we are trying to anticipate and trying to get an understanding of that. And a lot of that has to do with partnerships and relationships with people that, the OEMs of some equipment. So we're not trying to reinvent or to relearn things that people already know. We're just trying to make sure that we have the team ready to really solve any of those challenges. So that I think is probably easy to imagine. What scares me the most is managing the growth, right? I mean, I think we have, again, it's a disruptive technology, it's a disruptive business model, and there are ample opportunities to put this to use once we prove that it works. And just managing that growth and how do we do it, I think, is going to be the important thing. And again, the beauty behind what we're doing is, with the folks that we know and the relationships that we've built, we have a lot of people that are ready to either join the team fractionally or full time to really help us manage that growth and be successful. It's interesting, the technology, as exciting and as interesting and as difficult as the technology is perceived to be, it's the interpersonal dealing with people that's actually the challenges. And anyone that runs a business probably knows that, right? It doesn't matter how cool your stuff is or how great it is. You got to be able to sell it. It's got to work. You have to have that trust. You have to have that reputation. So what we're doing now is we're trying to grow that side of the business.
No, that makes a lot of sense. Yeah, I see the question coming in. I'll go ahead and
and I read it too. No, the first pilot is not contingent on this funding raise. So what we're doing with this funding raise, it's actually a really good question. So it's a relatively small amount of money if you consider things. What we're doing is we wanted to be able to raise enough money to where we could build these lab prototypes, finish the testing, get the data ready, so that we can go out and sell to the world what we're doing. The first pilot is absolutely not contingent on the raise. Neither is any of the other business. What we're doing right now is we are building prototypes, and we are getting some of the the sales and marketing in place to move forward. And that's why this is smaller. And we don't have any plans to go beyond that right now. On NetCap, our goal is it's the same as it's always been. We want to raise what we need, not what we want. And we want to do that because we want to empower, reward, whatever word you want to use, the people that come in early. We want to maintain as much equity to the team as possible as we grow, so that when we can have a success, that we can reward everyone, that we can maximize that for the shareholders, which is our focus.
Absolutely, absolutely. And you've proven to be able to do that in the past. Obviously, already raising over $1 million for being Nano, and then here passing the $100,000 mark for Invicta Water. So it's really helpful, I think, for that question and to be able to understand that this is a piece of the puzzle, but this is not, like you said, the project is not contingent on this fundraise, which is really good. And we're talking about the future of the company, and you mentioned this PFAS-free label. Any idea on the timing for that? I know that's a little bit of a long, maybe a slightly longer term project, but can you talk a little bit about that label?
Yeah, so I have, this is something, I don't know that we would be to have a PFAS free label. There's really two pieces, right? You have to have the process that removes the PFAS, and you have to have the organization that verifies you are in fact PFAS free. I don't envision Invicta Water ever being that laboratory. I think there would be at least a perceived conflict of interest if we're providing you the product and we're telling you that it's PFAS free. So a lot of that's going to do with the industry. There are some standards and some test standards that if you follow those and you have results, you can declare that you've removed some portion of the PFAS. But I believe that the industry is evolving in such a way that there will be laboratories, there will be certification organizations to provide that. And then what we'll do is we will likely, partner might be the wrong word, we'll collaborate with them so that we understand their testing methodologies so that we can provide them samples to show that, yes, what we're doing is in fact PFAS free.
Super exciting. Yeah, I probably need that third party independent validation is probably a good piece of the puzzle. And then people are asking, how difficult will it be to move from prototype to commercialized product, either in home use or municipal water treatment system? Good question.
So again, what we're doing is we're using a technology that can do a gallon per minute all the way up to millions of gallons per day, or a gallon per day to millions of gallons per day. It's bigger pieces of equipment. So I don't ever want to understate the challenge going from the small scale to the large scale, because there's always things that you don't anticipate. But from what we understand, it should be relatively straightforward. Again, we're partnering with other folks in the industry with some of the OEM equipment that we're going to have built and use. And that's what they do every day. So where our technology comes in, it will be on the sort of, I would say, the leading edge before we discharge the water. That we understand quite well. So it's how does that interact with everything else? I believe it will be a challenge, but I believe it is something that we can absolutely overcome. And I don't expect to have too large of a learning curve. Again, the pilot that we are working towards, I would say, is probably on the smaller end of a waste treatment plant. It's not in a huge city, so it's not millions and it's not tens of millions of gallons per day. It's probably on average 3 to 5 with a max of 7. So it's going to give us a good place to start that prototype. But we envision that essentially everything we're doing is off the shelf equipment and off the shelf technology. So it shouldn't be. It's not like we're inventing it. I don't want to say it should be easy, but we're prepared for lots of different scenarios and contingencies.
Yeah, not going to be smooth sailing, but you've already invested in infrastructure. You've proven a ton already, and then the plan is to continue to you control for a lot of the harder things.
Yeah. Now, when you get into the home use, I do expect the wells and the under the sink is probably going to be a little bit more of a challenge because we're shrinking it down to such a small form factor. But I think we've got a good head start on what we're doing there. We even have a few people that have volunteered to put something at their home when we want to try things out. So I think the well is probably going to be faster than the under the sink. And then, as one of the questions was pretty astute in noting that filter, since it doesn't have UV, it's completely different. So that we could make pretty quickly. But again, having something incorporated with UV light is going to take a little bit of time. The beauty is, if we figure out how to do 2 or 3 million gallons a day, there's a huge market that we can address right away. If it takes us a little bit longer to get to the 10 to the 15 to 20 million gallons per day, that still fits into the roadmap. But we don't have to do the biggest first, which gives us flexibility to not only create products and grow the business, but it gives us time before we have to do something like that.
No, that makes a lot of sense. And then I did mention your previous Netcapital raise with being Nano that raised over a little over $1 million. So let's talk a little bit about how Invicta Water relates to being Nano. Is Invicta Water wholly owned by being Nano, and what does that mean for shareholders?
So it was before the Netcapital raise, it was wholly owned. So every single share of Invicta Water was owned and assigned to BNano. Now, since we started the NetCap raise, obviously the shareholders now take a little bit away from that whole ownership. So there's very little. But when we first started BNano, our vision was to have these other companies that are using the technology but could be self-sustaining on their own. And that was the model that we presented since Jason and I first thought of this on just a sheet of paper. And even with our founding angels, that was the model that it did. So yes, it was wholly owned. So if you are a shareholder of BNano, you are indirectly a shareholder of Invicta Water, and you will participate in the success of Invicta Water. Our goal is to reward our shareholders at every level. If you are a direct investor into Invicta Water, you are not necessarily a shareholder of BNano unless you have also invested in BNano. So it is two separate entities, but BNano does own the Invicta Water. And we thought that was important for a number of reasons. One, it's completely different. Being a materials company working on materials that will be turned into other things is different than actually building and installing and maintaining systems for water purification. So it's going to require a completely different skill set as we grow, sell, and maintain that business. But we also saw the opportunity to have an international marketplace with water, right? There is a U.S. document out of the White House, the global water strategy, and it states clean water for the world. BNano, because of how that IP works and everything else, there are certain places in the world that we don't sell to or participate with. But water, it's easy, right? It's every single person on the planet, and we fundamentally believe that. And it's important enough to where we wanted to make sure that we had an organization that could address all of these different things. So it is wholly owned. Again, our shareholders are always first in mind. I think we did some presentations as BNano on NetCap where we talked about we would have a wholly owned spin out for the water company. I believe it was probably this Fireside chat for BNano all those years ago. And that's exactly what we did.
Yes, I love it. We've been talking about this for quite a while, and so I'm grateful to be seeing it come to fruition right now. And I've always thought that this is an incredible application. And I do commend you on appreciating that, clean drinking water is not a uniquely American need. So I do appreciate the international appeal there. Wrapping up here in the last couple of moments, are you concerned, or are there concerns around the idea that the crystals being used to clean and filter out the PFAS might themselves escape into water supplies? Can you talk about the safety?
Yeah, again, we're not really. I mean, are we worried about it? It's something in the back of our minds, but what we believe is the way we've designed the system where it shouldn't happen, right? So when we talk about it, we have the stripping, the enrichment, and the destruction. Our crystals will be physically present in the destruction. And then the way that this is set up, and again, there's a very simple drawing of this. And I expect we'll have a more detailed explanation of how things work, a video that we'll put out here shortly to maybe address this a little bit better. But the way that it works, again, the crystals will be in that last piece. And you can put physical filters, very simple physical filters in line, like a HEPA filter, that would potentially capture anything if it did escape. But by the way that the technology works and by having these safeguards in place, we don't expect there to be any escapes. It's something you can test for, instead of just saying it, it's something that we can certainly prove, but that's not something that we're concerned about.
And the graphic that you're referring to, is that the stripping, the enrichment, and the destruction graphic?
Yes, absolutely. And you can see that kind of. I'm sorry?
Oh yeah, no, I was just thinking I could just put that
absolutely. Yeah, you want to show it? Yep. Yeah, so you see that there are from the stripping, you move forward to your waste stream moves forward, and then you have a clean water return. So in the last box, the PFAS destruction is where we will have the crystals, and that water is returned to the previous step, which then goes back to the destruction, so that we have that continuous cycle. Now, obviously, there are some details that is doesn't describe everything that we're doing, but you have simple technologies, backflow preventers like you have in your yard, and some other things to prevent water from going where you don't want it to go. And with physical filters, you can block those from escaping.
Perfect. Thank you so much for that. And then I think this will probably be the last question, then I'll kind of start to wrap things up with closing remarks. So, and I know the answer to this, but I'm going to let you have the opportunity to share. Is BNano a publicly traded company or still private?
It's still private. Yeah, it's still private. We're not public. we're engaged in growing that business on a number of different verticals as well. We're still, I would say, in the growth stage. Nothing's off the table. No decisions have been made, but we are still private.
Perfect, perfect. Thank you so much for that. And then with the last couple of minutes here, I'm going to use this as an opportunity to thank all of the very thoughtful questions that came from the attendees. Appreciate that engagement. Obviously, thank you so much, Steve, for all of your time here today. Reminding folks that you can go directly to netcapital.com and search Invicta Water to learn more from the offering page. And if you're so inclined, you can invest. I've also added a link to that into the chat feature as well in Zoom. So you can just select the link, or you go directly to netcapital.com/companies/Invicta Water, where you can go ahead and learn more. And of course, you can invest. Okay, so that was the last little reminder. So as we bring things home here, Steve, closing remarks. Why is now the perfect time to go to netcapital.com and invest in Invicta Water?
It's perfect time. We're on the cusp of really growing, right? This is a relatively modest raise, and this is enough to get us to get us all the information and all the data and the prototypes to show that it works. We are already engaged with the potentially the first prototype that we expect to be able to get into details for shortly, and we have a number of other people that are ready to be first, second, and but for us, this is, it's much more than a business. I guess there's no other way to say it. What we have found is, we're passionate about material science. We're passionate about emerging technologies. We're passionate about disrupting and thinking differently. And when you can combine that passion with finding something that can clean water and truly change lives, it's not hard to wake up every day excited to go to work and to really to put forward in things. Everyone has families with health issues, right? And we're no different. There's been people that we know, that we love, that we care for, that likely because they've been exposed to water over the years has given them health problems. If we can find a way to not have anyone else go through that while at the same time growing a business, helping our shareholders and helping ourselves, but just by doing the right thing, it's hard to find that combination, right? As excited as we are about some of the technology that we've done with this boron nitride nanobarbs in other places, I can't think of anything else that could potentially have the impact as cleaning water would have. Water is a strategic resource, right? They talk about things that are going to run out. You don't have to look far, right? In the news every day, the Colorado River is drying up. There's other places. San Diego is trying to figure out how to get water from the Tijuana River, but it's polluted. All these different things. This is a challenge. The Middle East, how do you get clean water in the middle of the desert? How do you do this? This is just one little piece that can help solve some of those problems. For us, is fantastic. Being a part of that is incredible. Knowing that things that we have been able to create, invent, patent can enable this, it's amazing. It makes, when you are having that conscious side of capitalism, to me, I think that's the perfect innovation, the perfect thing to do. We're doing the right thing and growing a business at the same time, and it's what we're really excited about. So we would welcome anyone to join the family, either by investing, send us an email, ask us a question, make a connection. We love it all. And again, we tell this to everybody. There's much more value to the crowd than just the investments that we get. The people that we meet every day, it's amazing. And there's people that we would not have met if we were not doing things like this. And some of those people I'll be friends with forever. They'll be working with the companies that we have. So we're grateful. We appreciate it, and we're very glad to be a part of this. And for those of you guys that don't know Eric was the very first person we ever talked to at Netcapital. And when we first met him, we didn't really understand it, but it seemed like it was the right thing to do. And he's, been part of, I would consider him part of the team almost. So thank you, Eric, for all you guys have done. We appreciate it.
Oh, no, thank you so much, Steve. I'm grateful to be a small piece of the puzzle of the Nano and Invicta Water story. And I will be telling the story, I hope, for generations to come. So thank you so much for your time. Thank you for your kind words. For those who are still looking for a little bit more, kind of understanding about PFAS, I do think that the Dark Waters movie was a great intro to the topic. So if you haven't checked that out, go and check that out. I know there's a link to the IMDb on Invicta Water's offering page. So again, thank you so much for all the participants. Thank you for your time today. Thank you for your thoughtful questions and engaging with the Q&A. The link is still in the chat, but again, you can go to netcapital.com/companies/Invicta Water, where you can review the offering page, learn more about what Steve is building here. And if you're so inclined, you can invest. So thank you so much for everybody. Thank you so much, Steve, for your time today. You're a seminal issuer, and we're always grateful to be working with you.
I appreciate it. Thank you, Eric. Thank you very much. And thank you to everyone. We appreciate the opportunity just to talk to you today. So thank you.
Have a good evening, everyone. Thanks.
Bye.